need to see, I'm going to let W equal the set of all functions in my set of continuous functions, such that f is differentiable. I'm going to show this subspace. I'm going to use theorem 45 to do this. To do this, I first need to show that the 0 element is in there. The 0 element is z of x equals 0. But z prime of 0 of x is always going to be equal to 0 because the derivative of 0 is 0. So z of x is differentiable. Right? We know that constant functions are differentiable, in other words. So z of x is in W. So what do I need to show? I need to show that W has a 0 element, which I just showed. I'm going to need to show it's closed under addition, and I need to show it's closed under scalars. So 2, I'm going to let f and g belong to W. Then the single element f plus g is differentiable as the derivative of f of x plus g of x is equal to f prime of x plus g prime of x, which works. So f plus g, the single element, is also in W. So in other words, it's closed under addition. Finally, I'm going to let f belong to W. I'm going to show you that if a is a scalar, af is also differentiable as the derivative of af of x maybe I should say this up here. Right, this is what we're interested in, and that's equal to these two things separately. So the derivative of this is equal to the derivative of that, which equals f prime plus g prime. So similarly here, the derivative of a times f of x, because that's what a of f means, af means, is that it's just a times f of x, which is equal to a times the derivative of f of x equals a f prime of x. So the derivative of this thing, I know what it is, because f is differentiable, so it's just a times f. So in other words, what have I shown? I've shown the 0 element is in W. I've shown that the sum of any two of these functions is in W, because the sum is going to be differentiable. This is what tells me whether it's in or not. And I've shown that a scalar multiplication of anything in W is in W. So these three things hold. So by theorem 45, W is a subspace.